Okay, everyone. Hopefully, everyone can hear me here in the audience and online. And this is the last in our series of talks in this HEAS Seminar Series in human evolution in the Palaeolithic. And we're really delighted to finish up this week with our speaker, Professor Nick Ashton from the British Museum in London. Those of you that were here the last seminar would have seen Vitaly Usik and Roman Garber talking about early humans in Europe and the dates for this, based on their recent work in Eastern Europe. And today we're really delighted to have Nick extending this theme and talking about his research in terms of 400,000-year-old material from the British Isles. Nick has been a curator at the British Museum since 1983, and it's hard to believe, but that's because Nick did his undergraduate degree at UCL, and then he went straight into work at the British Museum as a junior curator, I guess. Would that be right? Junior curator, yep, probably. Yep. But since then, he's become internationally known for his research into the earliest hominins and their adaptation in Northern Europe. And he's led some internationally really important excavations at some of the most important lower Paleolithic sites, such as High Lodge, Barnham, Elvedon, Hoxton, and Haysborough, of course. And he's really one of these guys that is interdisciplinary to the hilt. He works with lots and lots of people. In fact, as he came in here, a couple of people that he works with have already got in touch with him and has said hi and so on. From 2001, through this amazing funding from the Leverhulme Trust, Nick was a central person involved in the Ancient Human Occupation of Britain project, directed by Chris Stringer. And later, this was extended by the Kaleva Foundation for the Pathways to Ancient Britain project. So this incredible funding has led him to do some really amazing work, which we're going to hear about today. And in 2024, he was awarded the Graham Clark Medal for his contribution to archaeology. And based on publications and his amazing publication record, he was awarded a PhD from Leiden University in 2010, presented with the Henry Stopes Medal from the Geologists Association in 2018. And he's also an honorary professor at UCL and Durham. So it's with great pleasure that we welcome Nick to Vienna to give his talk. Nick, over to you.
Thank you very much, Tom. You reminded me of a few things I'd forgotten, but it's been a long time. And thank you very much for inviting me to give the talk here. This is primarily, well, it's going to start in Britain, but hopefully some of the research we've been doing in Britain from roughly about 400,000 years ago will have relevance to how we begin to think about interpreting the European evidence, particularly that of Western Europe. So the title of the talk is Past Society and Culture, and based on, in part, on excavations at the 400,000-year-old site at Barnham, and then I'll extend out from that. First of all, for those of you who've probably got less of a background in the Paleolithic, down the sort of left center of this slide, this sort of curve here, it's probably a curve you're all familiar with, and this is basically the isotope temperature curve going back over the last million years, and the peaks on the right are the warm phases, the peaks on the left are the cold phases. So really complex climatic sequence over the last million years. For Britain itself, we go back probably to over 800,000 at sites like Haysborough, and then later at Pakefield. But it's really the central block, what I've called here stage 2, when Britain's a peninsula of mainland Europe, roughly between 500,000 to 300,000 years ago. And here we seem to have not necessarily continuous population in Britain, but when population is in Britain, we have larger populations, there are more sites, and we think there's more sustained occupation during this period. During this period itself, this sort of breaks down the local terms for this period. We've got the Cromerian interglacial, that's marine oxygen isotope stage 13. You can bear these in mind for those less familiar with these terms. Then we get this big glaciation, the Anglian glaciation. This was the largest glaciation that came over Britain, stage 12, about 450,000 years ago. And then important for this talk is the Hoxtonian interglacial. And this particularly warm period, similar climate to today, we call it stage 11, dating roughly to 400,000 years ago. You've got various well-known sites, Swanscombe, Clapton, Hoxton, other sites, and of course the site of Barnham that date to this period. And it's Barnham that I'm going to start off with. So that's the background. This is how Britain may have looked around about 400,000 years ago. The river systems were different. But importantly, we probably through most of this time still had a link with mainland Europe, predominantly across the North Sea Basin. The North Sea Basin has been subsiding through time, but 400,000 years ago, it was more or less at modern day sea level. So there was probably a land link between mainland Europe and Britain at this time. And you can see the array of sites that we get in Britain and indeed in northern France for this period. But it's primarily in East Anglia, north of Cambridge. It's about half an hour out of Cambridge, slightly to the northeast, an area that we call the Breckland. It's on the Suffolk-Norfolk border, for those who know Britain a little bit better. And we've got several main sites, and I'll mention all of these sites in passing. You've got Elvedon over in the north. To the east of that, you've got the site of Barnham, and then to the southeast, only 10 kilometres to the southeast, you've got the two sites of Devereux's Pit and Beech's Pit, and I'll be drawing those into the talk. So let's go to Barnham. Barnham's set in farmland. It's an old, very small clay quarry. The clay was used to make bricks for the local estate. It's now completely overgrown with nice, luscious oak trees and various other vegetation. So very nice, shady location. It's had an extensive history of field work, being a former clay pit for the local estate. It was opened up in the late 19th, early 20th century, and it's during the early 20th century that artifacts and fauna were first discovered. There was field work by Patterson in 37, further field work by John Wyman in 79, and then we had our first excavations there between 89 and 94, and then new excavations from 2013, and we'll probably be having our last season, I say season, 2 weeks work, in a few weeks' time. This is various shots of the work that took place between 89 and 94, just to give you an idea of how the site looked. This is the more recent field work. You can see these big brown clays there, the brick earth. That's the sediment that's been used to make bricks. Two of my colleagues, I meant to say at the beginning, this of course is very much a multidisciplinary piece of work, and the various names listed at the front. I'll mention them again now. Simon Parfitt on the left, Simon Lewis on the right, and other colleagues, Rob Davis, Marcus Hatch, and we've been doing work with numerous other people at the site, including Nareka, who's sitting here today, has worked on the micromorphology, indeed only just last week. The sort of scattered array of excavation trenches is partly due to sort of trying to get around the big old oaks that we don't really want to disturb. Indeed, their rooting systems would disturb the sediments underneath. So that's the reason for the slightly random array. But we've got area 3 in the middle, which is where most of the fauna comes from. And we've got areas 1, 2, 4 and 6 on the edge, and 4, and this is where most of the archaeology comes from, on the base, edge of the basin. Unfortunately, the sediments here are decalcified, so we don't get fauna preserved on the edge, but we do have a rich faunal sequence in the middle. And this is a cross-section through the site, area 1 and area 4 and area 6 on the edge. You can see this grey sediment. This is the feather edge of lake sediments, which on the edge is only about 30 centimetres in depth, and this thickens out to about 5 meters of lake sediments in the middle. I say lake, we're really dealing more with a pond. It's probably about 4 times the size of this room, not much more. So it really is a small feature in the landscape. Underneath those lacustrine sediments, we have on the edge, we have that cobble band. That's a lag gravel on the surface of a much deeper series of sands and gravels, which are all glacial in nature. And you also have tills. So we have a glacial sequence at the base. We think this dates to stage 12, or the Anglian glaciation, to about 450,000 years ago. Then you have the lake basin filling out up from the end of that glaciation into the following interglacial. We've got a nice pollen sequence going through that, going from cool conditions to fully temperate conditions at the top. And then as the basin dries out and fills up with sediment, becomes choked, you get vegetation encroaching on the edge of the basin, which eventually encroaches across the top of the basin. and this forms the Palaeosol that you can see that black horizon coming across from the edge of Area 6 across Area 1, down across the top of Area 3, sealing that sequence and across, of course, to Area 5. So you've got glacial sediments at the base, this interglacial sequence, and then Palaeosol, and then you've got colluvium coming in over the top. So that's the basic sequence. And you've got archaeology occurring in really Unit 5, the top part of those lake sediments on top of the cobble band as well, Unit 4, but also within the Palaeosol. We've dated the site by various means. You've got the stratigraphic evidence. It's the only glaciation that came over that area. So those glacial sediments are almost certainly stage 12, the Anglian. So the simplest interpretation is the sediments that fill up that basin are from the following interglacial. And this is supported by ESR dates on quartz. There's also amino stratigraphy done with Kirsty Pankman, which suggests a stage 11 date. Then you've got the mammalian bar stratigraphy, again supporting a Hotznean age. I should say the Hotznean is the first part of stage 11. Stage 11 we divide into 3 parts, C, B, and A, and the Hotznean we attribute to MIS, marine isotope stage 11C. And again, this is supported by the mollusks. And the palynology fits again with what in fact is the first half of an interglacial. The basin is too small, fills up with sediment, so it's only the first half of that interglacial that we get recorded within the basin. So that's how the pond, a very, very, very small lake, not much bigger than a puddle, works. It's probably fed by small streams or maybe springs. Definitely got an outlet because we've got migratory fish occurring within the basin. And you can see in the middle, Unit 5, there's much thicker 5 meters of lake clays in the middle, which thin out to about 30 centimeters, Unit 5 on the edge with a cobble band underneath and the Palaeosol stealing that sequence. So it's quite a nice sequence. And it took us many years to fully understand it, but that's we're fairly sure that's how it works. This is really a sort of bit of industrial archaeology. Fortunately for us, they didn't take all the clay away. They left big bulks of grey clay scattered about in the middle of the basin. So these form perfect blocks from which you can actually see the stratigraphy, but also excavate them down in a controlled fashion. And there's been a huge amount of sieving. Each year, there's something between 15 and 20 tons wet sieved, sort of 1 to 2 millimeter mesh, and a huge array of fauna has been recovered. This is just a tiny fraction of some of the material, but it's in terms of fauna, it's the richest Hotznean site in Britain by a long way. In terms of the range of species that we have, the number of those species we have, whole array of different things, and some exotics for Britain as well, things like pond terrapin, which we don't get in Britain today because the temperature's not quite warm enough. Red deer, lion, elephant, you name it, we've pretty much got it. We also get cut-marked bone, not very much of it, but cut-marked bone, which allows us to begin to link in what's happening in the middle of the basin to what's happening on the edge. We've probably got 2 parts of a human fibula found in different years. We're sort of ruling out all the other options. At the moment, we can't find any parallels, so we're comparing it to a lot of the SEMA material from Atapuerca, similar sort of age, where they've got lots of this sort of material which they're sort of yet to really look at, so we can begin to compare them together. And we've also got flaked bone, flaked elephant bone, and a few flakes, which is quite nice. So ways in which we can link what's happening in the middle of the basin to what's happening on the edge. And we also get occasional artifacts occurring in the middle of the basin, but it's taken many, many seasons' work to build up that the size of those artifact assemblages to make them comparable to what's going on at the edge. And this is a general reconstruction of how it might have looked. Nice interglacial environment during the human habitation. As I said before, most of the fauna comes from the middle, area 3, the deeper part of the sequence, but the decalcified areas on the edge, this is where we get the archaeology. And this is one example of that cobble band with a thin horizon of feather edge of the lake sediments at the edge of the basin. Initially, we thought we were dealing with a single assemblage, but over the years, we've managed to establish that we're actually dealing with two very, very distinct assemblages. And we're talking about several thousand artifacts in each case. And the green represent what we call a non-hand axe assemblage. It's an assemblage consisting of cores, flakes, flake tools, but not a hint of hand axe manufacture. No hand axe manufacturing flakes, no clear use of soft hammer. And then you get this dramatic change where we get hand axes and an awful lot of hand axe manufacturing debitage. Façonnage even. So we've interpreted this as two different human groups occupying the basin. The change we think is too rapid to be a sort of in situ. Suddenly somebody comes up with an idea, oh, let's make hand axes today. We think it's a different population coming in, and that's our interpretation of the site. And the core and flake assemblage is predominantly associated or purely associated with the top end of the lake sediments, and the hand axe manufacturing material and the hand axe assemblage is associated with the Paleosol. So again, you've got this clear stratigraphic distinction. Some examples from the middle of the basin of the core and flake assemblage. In the middle, it's really sharp. On the edge, it's more rolled, stained. And on the right, we have some examples of the hand axe assemblage. Not many hand axes, 8 in total, 4 of which we found last season. So they're incredibly rare. For years and years, we didn't find any, just the evidence of their manufacture. So I mentioned pollen right at the bottom, right at the end of the previous glaciation, around about 425,000 years ago, we get the first hints of warming climate. We get a bit of vegetation encroaching, grasses and dwarf shrubs and so on. And then the birch begins to colonize, followed by the pine. And by the time you get to the top of the sequence, you're in a fully interglacial environment. And in Britain, we divide these pollen zones into Hotznean 1, 2, 3, and 4. So the top of Hotznean 2 is more or less halfway through the interglacial, and the pollen zones, this is based on other sites, is pollen zone 2, Hotznean zone 2 is divided into A, B, and C. And at the top, we're probably dealing with Hotznean zone 2C, just prior to the change to Hotznean zone 3. So we can really begin to date this quite accurately. So that whole sequence runs between about 426,000 through to 415. But it's only right at the top of that sequence that we get the first artifacts appearing, these hard hammer flakes and cores and flake tools. And then as the Paleosol develops, which is probably during zone 3, we haven't got pollen from that horizon, but nonetheless, the simplest interpretation is that that's zone 3, roughly about 415,000. So you can see how rapid that turnover is in terms of population, if we're correct in that interpretation. We could be talking, 1 or 2,000 years, perhaps less, perhaps a little bit more, but it's a very short period of time. And you can begin to think about these populations almost on an ethnographic scale, but 400,000 years ago. But it's only because of the pollen that we can do that, and the mollusks to some extent. We also get evidence of heated materials at the site. In Area 3, we get occasional charcoal, but can't really do anything with that. We get concentrations, really marked concentrations of heated flint in Area 6 over on the eastern side, southeastern side. And then finally, I went to have a little nap in nice shady oak place 2 or 3 years ago, and thought, I'd be interested to have a little dig here on my own, nice and quiet in sunny afternoon. And lo and behold, I thought we found some heated sediment, and indeed we think we have. And numerous people have been involved with this. And I'm really glad that Mareka is here to field any tricky questions about the various techniques that we've been using from FTR. Well, it's the classic techniques that hopefully people use nowadays, as you can see on the top there. And only last week, Sally Poor was in Vienna working with Mareka on the some new micromorphology that we're undertaking. So any tricky questions on whether or not this is heated sediment, whether it's heated by humans, which we think it is, then field in Mareka's direction. She's kindly agreed to do anything tricky, technological that I don't understand. So you can see, I won't go into any detail on this. It's the subject to publication at the moment. But just to say, it's a fairly secluded area of heated sediment. It's one of the things we're trying to work out with the micromorphology. But really interesting feature. The first, what we think is heated sediment from the site after, well, since starting field work in 1989. So fantastic. But it's also associated, and in fact, so you can see where that heated sediment is over on the top right, that pink blob. And this is associated with Unit 6, with the Palaeosol. It's part of the Palaeosol above and below. And that's the artifact distribution over fieldwork since 1989 in that Palaeosol, very thin distribution on the left, on the western part of the site. And as you get towards where the heated sediment is, the concentration seems to build, and we get heated flint artifacts in that area, including previous season, one heated hand axe, which is this one in the middle, or part of a hand axe. It's heat shattered. And then we recovered 3 further heat shattered hand axes in 2024. And there are also 2 bits of pyrite, which we're thinking about. So our interpretation is that we've got human use of fire at Barnham associated with this hand axe assemblage, and dating to about 415,000 years ago. And so how does this compare to other sites in the area? Beech's Pit has been long published since early 2000s by John Gowlett and Richard Priest. There they also interpret some of the sediments as being heated. There's still ongoing work and ongoing publications on that, with Sally Hoare as the main author. So that hopefully will be published in the next 12 months or so, or earlier. But this is one of the areas that they interpreted as being heated. But the work that Sally has done suggests that you've got repeated heating at the site. And again, the interpretation is that you've got some ongoing use of fire by humans. And this Beech's Pit we can connect to Barnham through the mollusks. This is again work by Richard Priest. And this probably more or less equates with the Unit 6 at Barnham. So we think pretty much contemporary and associated with hand axes again. And this is a new site, Devereux's Pit, being worked on by Rob Davis. It's ongoing work. And there are hints of heated flint at the site, or there is heated flint at the site. Whether or not it's associated with humans, we don't know. Using Kirsty's done aminostratigraphy, dating it to stage 11, so it's broadly contemporary with Barnham and Beech's Pit. And one of the interesting things here, you've got what is termed in the field as slightly clayey sand, above which you've got sandy clay. You can probably just about see a subtle change in color, possibly texture. These are largely very gentle slope sediments coming into a wet basin, very gently forming. In the lower sediment, you've got hard hammer cores and flakes, and then immediately above that, you've got hand axe manufacturing, debitage, assemblage. Again, this very, very clear divide between these 2 assemblage types. And we think this provides strong support that we're dealing with a population change, a population turnover in formal terms. And I think what's interesting, drawing these different sites together, we're dealing with a small part of the landscape, literally Barnham to Beech's Pit, talking about 10 kilometres, very short distance, chalk and till interfluve, Eldon over on the left. These are peripheral parts of the landscape. It's a landscape that doesn't have caves, but if you want a sort of safer part of the landscape, these are the sort of locations you choose. They're off the main rivers. Even the main rivers are pretty small, you know, they're less than the width of this room, so we're not talking about the Danube. We're talking about a tributary off a tributary off a tributary. These are the cul-de-sacs in the landscape, and associated with small ponds, abundant flint, good quality flint. Obviously, you've got small source of water. Barnham and Beecher's pit are associated with fire, possibly Devereux's pit, we don't know. No evidence of that at Elvedon, but we may have missed it. It took 30 years to find it at Barnham. So, and these are peripheral bits of the landscape. Devereux's pit and Beecher's pit, they're up against a sort of chalk bluff. It's a small cliff. These are the safe peripheral parts of the landscape. And I think if you link all these things together, use of fire and so on, we can begin to talk about home bases. And the first time really in the Lower Paleolithic, at least in Britain, in the absence of caves, that we can begin to think in this sort of way. And I really don't need to go into the importance of fire. I'm sure you're familiar with all these things, the practical considerations, the extension of food that you can digest, freeing up energy for brain development. And of course, I think what particularly interests us is focus for social interactions and all those things that might develop from that social interaction and structuring and enculturating the landscape. So I think once we can begin to identify a more persistent use of fire in Europe, then we're beginning to talk about fundamental changes in how society works. So I think it's a really important development. I'm not saying it starts at 400,000. There may be much earlier sites that we haven't yet identified, but certainly I think we can begin to identify it from at least this time. Because of the pollen and because of the mollusks, we can begin to link these localized sites with other sites in Britain. So you've got Barnham, Beecher's pit and Devereux's pit. And this is through the pollen and mollusks, I should emphasize, not through the archaeology. So the correlation is done through pollen and mollusks. We can begin to link them to Clacton, Swanscombe, other sites like Hoxton. But what it does show is that when you begin to link them through the pollen and the mollusks, the archaeology actually fits into this population change. The green representing the core and flake assemblages, followed by, very rapidly, we think, the hand axe assemblages. And we can go a step further than that. These hand axe assemblages, if we look at the East Anglian record from all these sites that I mentioned, one or two others, compare it to the record from the Thames Valley, there appear to be changes in the form of the hand axes being made. In the Thames Valley, they tend to be more pointed. Swanscombe being the classic example of this. In East Anglia, they tend to be more ovate in shape. So we can begin to ask questions and play games. I have no answers here, but we can begin to think about, are we dealing with social territories between these two different groups? And you can play around with all kinds of modern parameters for similar climatic zones, environmental zones from recent hunter-gatherer populations. Fantastic work by Binford in 2001 that listed everything under the sun that over the last 100 years or so. And so you can begin to think about some of those parameters, what are the limits on human population density in those areas. And this is games, so I won't go further than that. We can say one other thing. Towards the end of stage 11, I mentioned that up till now, we've been dealing with stage 11C. Right at the end of stage 11, roughly about 380,000 years ago, we seem to get a different population coming in. These amazing, what are called twisted ovate hand axes. This is one spectacular example from Greenhithe, where you've got this amazing banded flint. And again, something I won't go into, but, was this intentionally chosen? That amazing shape, almost, pretty good symmetry. I couldn't do that. And then you've got this twist. If you turn it through 90 degrees, you get this sort of what's called an S twist on one edge. If you turn it through 180 degrees, you see a similar S twist on the opposite side. Incredible pieces. And these are repeated at various sites at the end of stage 11. So again, have we got a different population coming into Britain at this time? So what's encouraging populations to come to Britain? What's the mechanisms? What's the processes behind this? And perhaps we can begin to think of it in terms of climate change. If there's a shift in climate, then you might get a shift in population. We've got this sort of very narrow entry into Europe, and the first group, cores and flakes, climate's warming, beginning of the Hoxton interglacial. environments are changing. So maybe by chance you've got a population with this technology coming into Britain at that time. The second group with hand axes that you get at Barnham, that you get at Beech's Pit, that you get at Devereux's Pit, you get at Swanscombe. What's the trigger for them coming in? You're in the middle of an interglacial. During that interglacial, you get what in Britain we call the non-arboreal pollen phase. And in Europe, it's called the Old Holsteinian Oscillation, which occurs in pollen curves throughout northern Germany, Poland. You can recognize this event, the OHO. In Britain, it's the NAP. And something triggers deforestation of the environment. What triggers it? We don't know. Is it climate? Possibly. That's the latest thinking. Other ideas could be a meteor strike, or it could be volcanic activity. Whatever happens, it's a large-scale event across Northern Europe, and any change in environment like that is bound to have an effect on animal populations, including humans. So there's bound to be shifts in population, and perhaps these hand axe groups are coming in during that environment change at that time, about 415,000 years ago. During the middle of stage 11, you get climatic cooling, so you probably get depopulation or local extinction. And then you get this third group, the amazing ovate hand axes coming in around about 380,000 years ago. So perhaps we can begin to think of populations coming into and becoming extinct or leaving Britain in relationship to climate. So, these are the potential phases, but of course, where do they come from in Northern Europe? Of course, they could be coming down from Scotland, but I'm guessing not. They're almost certainly coming from somewhere in Europe, and we really don't know where. We can make various guesses. Perhaps the population without hand axes coming from Eastern Europe, Northern Germany, and so on. Maybe, but there are other areas in France and Italy that sites that have no hand axes in their assemblages. In terms of the dating, it's incredibly difficult to actually link them in. We're fortunate in Britain because we have this big glaciation, that acts as a big marker horizon. We have these basins that fill with lake muds, also artifacts, which we can relate to the pollen. Then we can begin to really narrow down the dating of those sites. In Europe, there are fantastic pollen sequences, but as far as I know, none of them are really associated with archaeology, and you can't make that direct link. There's a really good understanding of how climate changes in Europe from these large things in the Valais, in various sites in Germany and Poland. Really good understanding of how vegetation changes, but not really how it relates to humans. And trying to deal with different geological stratigraphic schemes, different dating methods. Tom will be fully aware of these. The contradictions that occur between different dating methods, it's actually really difficult. And here we're using things like ESR, OSL, U series, whole range of different things that you can use, Paleomag, but actually trying to relate these sites together is an absolute nightmare. Even fantastic sites like, the Atapuerca sites, the contradictions that are there in terms of the dating is really difficult. And of course, this is only dealing with Western Europe, and what's not mentioned here are all the sites in Eastern Europe, which the further you get away, the more difficult it becomes. So trying to understand where these populations come from is really hard, and at the moment, I don't think possible. So how can we begin to think of it in a different way, I suppose? So one of the things that we've been developing, particularly Rob Davis and myself, is thinking about looking at the evidence in two different scales. And we can look at the stone tools, which is the vast majority of our evidence. Trying to make any sense of the patterns is really difficult. Here again, I'm using green to indicate non-hand axe sites. And they occur, not just in Eastern Europe, but the sites like Schoningen or Bilzensleben or sites in Poland, but they also occur in Southeast Europe, Italy, occasionally in Spain, also in France. There's no clear pattern at this very simple division. And what you actually see is huge variation locally. So raw materials playing a huge part in what's been done at any particular location. And I think we have to think of these small populations just basically doing their own thing within within the confines of their particular environment until things shift. I'll come back to that in a minute. So local variation in stone tools, very difficult to make any sense of it. And these are just some examples. Bilson's lobe, and very much down to the type of raw material that you get there, a very basic assemblage. That not to say they can't do amazing other things. It's just the raw material doesn't allow them to express anything in that way. Same Polidara in Italy, literally next door to Castel di Guido, one side has no hand axes, the other side has hand axes. So, it clearly something going on. Condellarago, here you can see function playing a real part in the variation that you get. Some assemblages without any hand axes, others with hand axes. So trying to divide assemblages up on a hand axe, non-hand axe basis really doesn't work. There's much more going on. And I think, again, one of the things that you occasionally get glimpses of is continuity in cultural knowledge over long periods of time and through climate change. So certainly in southern Europe, and perhaps a little bit further north, you appear to get continuity in occupation, but also continuity in that cultural knowledge. And Condellarago is a great example. The stone tool technology, although some assemblages have hand axes, others don't. Basically, what's going on in terms of the background is similar stuff. And importantly, they're using the same range of raw materials. And some of these raw materials come from 30 kilometers away, 35 kilometers away. And that cultural knowledge, and I assume it's cultural knowledge, continues right the way from stage 14, which is 560,000 years ago, right the way through to stage 12, 400. So over 100,000 year period, you get the same use of the range of raw materials within that landscape, which is really interesting, I think. And you get the same at Ménez-Dréguin in Brittany, in Western France. You get continuity, I think, repeated use of fire with these hearths. This is a sort of, had been a cave site where the roof is now gone. But again, same use of a range of raw materials, some of which come from 20 kilometers to the north. So use of the landscape in the same way, I would suggest, by similar populations. And it's very different to what you're getting in Britain, where you get this sudden cultural change. There's also much more variation, I think, in the hominin fossil record. We've got very little of it, so it's very difficult to draw firm conclusions. We used to divide these into early Neanderthals or Heidelbergensis. And nowadays, I think most workers see it as much more complex. And there's a great paper by Robin Dennell and colleagues, I think in 2010, 9, where they talk about demes. And these are localized variations in what is largely a single population. And you get, again, a great example of this is the Thema material from Atapuerca. When that was first published, it was said to be Heidelbergensis, but now they've suddenly changed into early Neanderthals. I assume that's a change in our interpretation, not a change in the fossils. So Arareret has features of Heidelbergensis, but also of Neanderthals. It's much more complex than we have allowed for in the past. And I think, can extend DNA back to this period, and then amazing things will begin to emerge. So this local variation also sort of almost mirrors onto the variation that we have in stone tools. Variation in localized stone tool manufacture, variation in localized hominin populations. So I talked about two scales of analysis. You get these localized adaptations, which could be based on raw material, geography, environment, a whole range of other things like that. But then underneath that, and this is probably where it becomes controversial, I think what we have to try and do is use cherry pick, if you like, use the evidence that is preserved exceptionally. We have to accept, I think, that very often evidence isn't preserved. So we have to extrapolate out from where it is, where we have exceptional preservation, and begin to, or at least begin to think in the way of extrapolating out to the broader picture. So I would argue, and Rob, and the work that we've done, was would be that underlying this local variation, we have a much wider set of know-how and technological ability. And you can go through a whole array of things, and starting with fire, 400,000, you have a fairly consistent picture of fire use at various sites in Europe. Some need more evidence to demonstrate this. Mareka published a groundbreaking paper 2017, 16, 15, wow, 10 years ago, on Schoningen, which had been interpreted as fire, but the evidence really isn't quite strong enough to support that. So, you know, not necessarily not that off the list, but we need stronger evidence to say that it was human fire use. Nobody's really re-looked at the Biltslaven evidence. Terra Marta, probably stronger evidence from Ararera. I think, in my view, stronger evidence from Menes-Dragan. And there are probably various other sites that you could begin to add to this list. So some sort of pattern begin to emerge about 400,000 years ago, not just fire use in East Anglia, but also probably elsewhere in Europe. And the thing about fire, once you start using it, it's very difficult to stop. Because you become if you're using it persistently, your gut changes and you become reliant on it. Then, of course, we have amazing woodworking at various sites, but again, it's the exceptional preservation that we have to extrapolate out to. You know, it's not just that Schoningen they were doing special things. Incidentally, there's a recent paper published a couple of weeks ago that now suggests Schoningen is stage 7, not stage 9, just to complicate things. And this may well be the case. So I put both references there. And, you know, I think they've got good arguments to say at stage 7. So these amazing spears from Schoningen might be quite a bit later than we thought. Nonetheless, you've got Clacton spear at stage 11. You've probably got a whole range of other sites where it's not preserved, but almost certainly they're working wood. They've got to be doing something with these stone tools. And, you know, there's obviously use-wear analysis and so on, which would support that. And increasingly, we're beginning to recognise the use of bone tools, again from Schoningen, from a recent paper from Clacton with Simon Parfitt. These amazing hand axes made out of elephant bone from Italy. Incredible things. So, again, this is the exceptional preservation, which I think, you know, this is occurring all over the place. So I think, you know, geographically, so I think we can sort of fill in the gaps in between and suggest that these things are almost certainly going on the sites where it's not preserved. You know, amazing evidence of, I think, both hunting specialization and butchery. Boxgrove, stage 13, 500,000 years ago. Recent work by Simon Parfitt in the volume with Matt Pope and Simon Parfitt. Incredible evidence of skilled butchery. Everything from horse skinning, gutting, filleting, marrow extraction, and so on. Particularly the filleting, intensive filleting of the meat, and intensive marrow extraction. That was really appears to have been an important part of the diet. And then you've got other sites, Pondelarago in stage 14, they're specializing on reindeer. And then in stage 13, a shift still on deer, but red deer and fallow deer. Appears to be a good lookout post above the local basin and valley, and specialized in hunting or extreme scavenging of these particular species. And then Grandolina TD 10.2, dating back to stage 10. They've got specialized bison, both hunting and butchery. So, you know, things are going on all over the place in terms of hunting technology and butchery. And then also during this period, this is based on a paper by Mariel M. Monsol in 2020, beginning of evidence of early Levallois. I won't go into this. Various sites from Italy through to Britain, down into France, and probably into Spain, and so on. And then round about stage 7, round about 250, 200,000 years ago, you get these amazing Levallois points in Europe. This seems to be a rapidly spreading technology. These things are probably hafted. They probably begin in Africa. Katupan 1, South Africa, dates to about 500,000 years ago. There's question marks over the dating of this. It may be a bit later, but nonetheless, it's happening. Near East, it's happening. Here's an example. This will be a cave in Israel, and then Northern Europe, it's happening all within the space of a short period of time, this rapid spread of technology. And the really interesting thing here is that we're dealing with different human species. We're dealing with probably early modern humans in Africa and possibly the Near East, and we're dealing with early Neanderthals in Northern Europe. So this technology is not only spread rapidly, we think, but it's also cross-species, and that's pretty stunning. And yeah, sorry, I'll 5 minutes. Is that okay? Drawing all this together, Rob and I have just built what we can call the cultural mosaic model. And what we suggest is that in stable climate, you get localized populations becoming habituated within their local environment, within their local zone. They know the resource distribution, and the material culture begins to reflect those local resources, and it becomes embedded in the human group. And this is how you get traditions of practice and manufacture, and perhaps early indications of normative behavior. You get those repeated hand axe forms being made, and this itself can strengthen social bonds, has huge benefits for your social group. Great. Then climate changes. You get a shift in or change in the environment. You get a change in the resource distribution, certainly your fauna, and you always get shifts in population and changes in your localized territory. And this has short-term costs because you might get loss of population, as you probably do in Britain, increased competition for resources, destabilization of normative practice. So they're the short-term costs, but the long-term benefits, of course, are increased interaction with neighboring populations, acculturation, innovation of new technologies, and of course, really importantly, gene exchange. So I think this sort of maps on to those two different scales of analysis. On the left, you get that localized picture of what's happening within that localized area, which is very much a reflection of those resources. And then you get a shift in climate or environment, as in the NAP or OHO, and that's where you get greater flux in the populations and where you get interaction between those populations and perhaps local extinction, but importantly, exchange of new ideas and genes. These have been published in a couple of papers. If you want the details, ask me later. And that's really a summary of how we see things at the moment. And thank you very much for listening, and thank you to all our British colleagues and European colleagues for developing. It's very much ideas, so I'm very happy to be criticised and discuss all these ideas with you. Thank you.